I'm Ben Musson, Controls Engineer and Project Lead at Musson Industrial.
I'm Caleb Musson, a Process Control Engineer at Musson Industrial.
And I'm Reed Minchofer, a Controls Engineer at Musson Industrial.
Musson Industrial is a systems integrator based out of Hamilton, Ohio that offers a full suite of industrial automation services, from system design and SCADA and PLC programming to panel fab and instrument calibration. Musson Industrial is happy to be celebrating 30 years of business this year. Murakami's North American plant produces automotive side view mirrors, processing plastic into assembled mirrors with included electronics. This project transformed Murakami Injection's pen and paper logging process into a fully ignition-powered system with automated production, scrap, downtime, and changeover tracking. Before this project, Murakami's injection department was like a time capsule. Operators recorded defects as tick marks on a piece of paper, pallet labels were manually printed using an SSH connection to a terminal server, and injection department leads had to wrangle with an access database of molds, parts, and defects. 3 main goals were identified for the project. 1. Eliminate all operator paperwork. 2. Track all production information, production scrap, downtime, and changeover time. And 3. Push real-time inventory information into Murakami's ERP system.
Murakami uses a software called Bartender in order to manage the printing required for their production process. Bartender maintains connections to the printers, allows for the design of label templates, and exposes an API to allow us to print those label templates. We developed a custom module for Ignition that allows an Ignition gateway to connect to a Bartender server, configurably through the web UI, and exposes a full set of scripting functions to allow Ignition and Bartender to interact together.
Here we have a test operator HMI setup where the left side of the screen is in production and the right side is offline. In the plant, one of these is mounted between 2 presses, with the left side of the screen correlating to the left press and the right side correlating to the right press. For the demo, the left side is in production and the right side is offline. To return to production, we'll hit return to service and are prompted with an operator login, completely unique from the left press and the rest of the plant presses. We're then brought to a screen with multiple state options, but we're going to change molds. On this screen, the operator can choose the mold type, which filters the molds available. Choosing a different mold then updates the information given. Once the mold change is started, there's a sort of waiting room screen while the technician removes and replaces the mold in the press. After this is complete, we can go into startup. The HMI stays in the startup state for an indeterminate amount of time until the shots start making parts free of defects. Once parts are deemed acceptable, if the cavity information is correct and there seem to be no errors with the history, startup is complete and can be selected, triggering a login to proceed. At this point, production must be approved, but not before verifying the number of startup scrap, entering a part quota, and choosing how scrap is handled automatically should the parts be for service. For our demo, the scrap never incremented but would carry over from the startup shots on the previous page. The production target is entered on a custom number pad component to ensure writing only to the press intended. With all these entries filled and accurate, the machine is ready to enter production. The ideal state for the plant, production is essentially the home screen and the interface operators will spend most of their time engaged with. When a defected part comes down the line, the operator selects the defect and chooses whether the part is green for right-handed or yellow for left-handed, a color scheme long established and paramount to maintain for the technicians at Murakami. Doing so starts a fixed 5-second timer animation that regurgitates the defect and side chosen, also revealing a button that allows time to stop the entry. With submitting on a timer, there is no need for a third button press, and the operator can return to inspecting for defects, as well as create a queue by marking multiple in rapid succession. This is how operation proceeds until a downtime event, mold swap, or shift change occurs. A downtime event can be started by an operator with a button push, followed by a login. This stores an initial cause of operator-initiated downtime in the logs and opens up a space for comments. If further input isn't required, the event should be marked as over, but permits elaboration if the downtime reason is something more specific. The list of other possible downtime causes is pulled from those configured by the techs, and there is a toggle button to mark if the down was scheduled. Adding a downtime reason and a comment returns the user to the primary downtime page, giving the same options as before. Since 2 downtime reasons were just provided for the demo, we'll start production back up.
Here we have the injection config interface. From here, supervisors can configure presses, molds, defect and downtime codes, and material types, as well as view production analytics, including parts produced, scrap produced, downtime, and press state information. For example, to create a new mold, operators give the mold a name, select the material type and production schedule, then add the cavities that belong to the mold. These cavities can be named, and the parts that they produce can be assigned. The parts in this drop-down list are pulled directly from Murakami's ERP system. The presses that this mold can run on can also be assigned, as well as the production rates. Finally, scrap buttons can be added. These buttons are displayed to the operator during production, and from here, the supervisor can configure which parts are configured as scrap and which are configured as out of balance. This out of balance is useful for parts with handedness, like left and right hand. After saving the mold, it's now available to run at the press for production.
A consolidated print station was created to simplify the method of printing pallet labels. The process is as easy as scanning a Kanban, specifying the number of parts per container, and containers per finished pallet, all crucial details for the skid label. Print commands are sent by a custom module that handles integration between bartender and ignition. The connection is done from within the ignition gateway, with the print actions executed via script calls. Wrapping the proprietary BTXML syntax in an intuitive UI allowed for maintaining a simple way to make labels from a scan and keep a high-performance print queue. This page is also a reference for online presses, their states, and the elapsed time.
As a part of this project, Musson Industrial developed a fully custom theme for Ignition Perspective. This theme is based off of Google's MUI Joy library and works based off of the principle of applying style classes to specify color, variant, and size. There are 4 variants supported by the theme: outlined, plain, soft, and solid. A full suite of color with semantic meaning, like danger, success, and 3 sizes. All of the components in Perspective support being styled by these 3 properties. For example, we can change our button to a drop-down, and we get the same color, variant, and theme options available to us. This allows us to spend less time styling our components and more time making them do interesting things. In addition, the theme supports dark mode and system theme detection. We've decided to release this theme as an open source project. You can find the theme files, the source code, and more over on our GitHub repository.
This project was a major upgrade for Murakami. We were able to greatly increase the accuracy of production, scrap, and downtime data, while simultaneously making the process much simpler for Murakami's employees. The automatic logging of all parts to Murakami's ERP system ensures accurate inventory at all times, which is essential for just-in-time manufacturing. The system was designed with flexibility in mind. Murakami's employees can perform all the configuration for the system using the tools provided, and their design allows for easy integration with future systems, with the hope of using a vision system for automatic part defecting. Musson Industrial is proud to have successfully completed this project in partnership with Murakami, and we are happy to have been able to contribute to Murakami's success and look forward to future collaborations.